Good afternoon, students. Welcome to the next session for our subject, concrete technology. We have started our unit number 5, and in the unit number 5, we have completed the first half of this particular chapter. Which was the first half of this particular chapter? If you want to take a recap of the previous session, the first half is dealing with the creep. Okay, the first half is nothing but going to deal with the creep. Now, what is the creep? Definition also we have discussed, and the factors which are influencing or which are affecting the creep. That factors also we have discussed in detail about that particular point. Okay, so what is creep? Creep is a time-dependent deformation of the concrete structure. It's a time-dependent deformation of your concrete structure under the varying action of the loads. Okay, it may be the self-weight, it may be any other load which is acting on the body. Due to that, there is a deformation of that particular structure, and that is nothing but the creep, which was going to be happen. Okay, so this time-dependent strain, you called it as a creep. It lasts long for many years in a concrete structure, and it also depends on few factors. Okay, when was creep initially get started into our concrete body, when it was going to end? So everything it depends on the few factors that we need to consider in our concrete mix design, or when you are going to prepare your concrete. Okay. So some diagrams I have shown it to you for the same. This is one diagram for the creep. This is another one. Again, this is the cracks which are being developed, the deformation of the road structure. Then factors we have discussed, like concrete mix proportion. The first factor, how it has been affected, I think we have discussed in detail, so we are not going to discuss it once again. If you have any problem or if you are not understood that particular part, then please let me know. Okay, so that I will repeat that part once again. Then aggregate properties, that is the second factor which will affect the creep. Next, age at loading, at which age and what is the exact quantity or the intensity of the loading which has been there. Okay. Next factor, curing conditions. Then I think cement properties, temperature, and the stress level. Okay, the factors, all these factors we have discussed in detail. How mixed the proportion is going to affect the creep. Which aggregate properties we are going to consider it. Okay, whenever we are dealing with the creep, it may be the toughness, hardness, or the abrasive strength of that particular concrete, or sorry, of that particular aggregates, or it may be some physical properties like specific gravity, water absorption, how these are going to get affected. Okay, how these are going to affect the creep. Then age at loading. Okay, at different stages of that concrete structure, maybe after this span of 1 year, 2 years, 3 years, 5 years. Okay, what will be the creep which was going to be happened? That part also we are going to discuss. Okay, then cement properties, all the physical properties of the cement, like properties like specific gravity of the cement, fineness of the given cement, then consistency of the given cement, then setting time of the given cement, all these properties, they are going to affect the creep. Temperature, another factor, the weather conditions, and the stress level. Okay, what type of actual load is going to act upon that particular concrete body. Okay, so these factors we have discussed, so I will not take much time on this. Directly we move towards the next half of our chapter, that is nothing but the, I think, shrinkage. So with all this part already we have done it. All the factors we have discussed in our previous session. Okay, discrete analysis and all that we have discussed. How, what is the effect or effects of the creep on the concrete structure? That part also we have discussed in detail for your beam, for your column, then for the other structures like these stress structures are there. How the creep is going to affect it. Then last part, I think I have given you the example of the dam construction site. Okay, if the creep is going to occur on a dam construction site, that is, if there is a deformation, what will happen? Okay, so though it looks very simple, no sir, this is just a minute crack which was developed on a dam site, but It was not the minute crack. Okay. It may lead to the failure of a dam completely. It may lead to the failure of the dam completely if you are not going to take care of such cracks or such deformation. Okay. Actually, there should not be any deformation at first. If some cracks or if some deformation, if you observe it was started in the concrete body, immediately cure it. Because for such mass structures like your dam is there, maybe take the example of bridges also there. Okay, if some cracks are there on the pier structure, okay, these are not good for that particular structure. It will reduce the life definitely. Secondly, it can do a big impact. Okay, if the length of that crack goes on increasing, it will directly demolish the structure or it will directly deteriorate the structure very early, and that is not good sign for that concrete structure. So try to avoid the deformation as much as possible. Okay, so that you will have the good concrete structure body. Okay. Next part we are going to start is nothing but the shrinkage. This is the last half of this particular chapter, that is chapter number 5. Okay, let us start with the shrinkage. Yes. At first, we will discuss the definition. What is the shrinkage? I will use the pointer also. What is the shrinkage? So shrinkage is the shortening of the concrete. Shrinkage is the shortening of the concrete due to its drying, and it is independent of the applied loads. Okay, if there is a change in the volume of that given concrete body, if there is a change in the volume of that given concrete structure, then due to this change, there is a shortening of the concrete. There is a change in the volume of the concrete, and that change we can call it as the shrinkage. It may be due to the drying, it may be due to drying, and is independent of the applied loads. Okay, and is independent of the applied loads. So any type of load which is acting on your structure, it may be the self weight which is acting on the concrete body, it may be the live load, it may be the impact load, it may be the wind load, any type of load which is acting on the body. Okay, it is independent for the shrinkage. What is shrinkage actually? If you want to simplify it and if you want to remember it for a long time, shrinkage is nothing but the change in the volume of the concrete. If you have taken 1 meter cube of concrete and it shrinks due to drying, and it shrinks due to the drying, maybe there is a rise in the temperature, okay, and all the water gets absorbed. Okay, sorry, all the water gets evaporated from that concrete body. Okay, due to rise in temperature, the water gets evaporated from the concrete body. What will happen? Definitely, there will be change in the volume of that concrete structure. Okay, and that change we called it as the shrinkage. It is the shortening of the concrete body due to its drying. Okay. Now, change in the volume, it may occur due to other several reasons also. It is not like that due to temperature only, water gets evaporated from the concrete body, shrinkage is going to happen. It may be some other factors also which we need to consider. Okay. Let us proceed further. Shrinkage of the concrete is the time-dependent strain. What is shrinkage? It is the time-dependent strain measured in unloaded and unrestrained specimen at a constant temperature. It is very important for us to understand this sentence. The shrinkage is a time-dependent, definitely. It's a time-dependent strain measured in unloaded and unrestrained specimen at the constant temperature. That means whether we are applying the load on the concrete body or not, it is not dependent. It is not the major factor we need to consider. Okay, it is independent of the applied loads. Okay, so shrinkage, it is time dependent strain and it is measured in unloaded. That means we are not going to consider whether I am acting a load of 10 ton on the concrete structure or whether I haven't applied any kind of load. Just self weight of the body is there. So whichever the type of load which is acting, we are not going to consider which type of load is going to act on that particular concrete structure. What we are going to assume? We are going to assume, or our main focus is on the change in the volume of the concrete bodies. Change in the volume of the concrete body, which is independent of the applied load. Okay. Next. Yes, you can see here this shrinkage which was going to be happen. Some cracks are there. These are the alligator cracks you can see, which are developed on the concrete surface. Okay, these cracks you are going to see. Why these cracks are there? If you just see this particular portion, which the pointer I am scrolling, the water from that concrete body shrinks. It was evaporated, and the concrete body becomes like this. It has shrinked. Okay, this body you can see it is shrink now. Why it is shrink? Maybe there is a loss of moisture, or maybe there is a loss of water from that concrete structure. It may be any other reason. Okay, whether we have applied some load, no, it is independent of the applied loads. Okay, maybe this particular shrinkage was happened on a concrete body due to loss of moisture or due to the loss of water from that concrete body itself. Okay, the reason may be anything out of this. Yes, here. Yes, there is change in the volume. Okay, and definitely volume goes on reducing, not increasing. Shrinkage, it shrinks. Shrink म्हणजे काय रे? आकुंचन पावणे. Shrink म्हणजे काय? आकुंचन पावणे. ठीक आहे, नेहमी लक्षात ठेवा. आणि एक्सपान्शन म्हणजे ती बॉडी जी आहे ती एक्सपांड होते. ठीक आहे, त्याचं प्रसरण होत आहे. एक्सपान्शन म्हणजे प्रसरण पावणे आणि श्रिंकेज म्हणजे आकुंचन पावणे. कशामुळे बॉडी कॉन्ट्रॅक्ट होती किंवा श्रिंक होते? ज्यावेळेस त्यातलं मॉइश्चर जो असेल किंवा वॉटर कंटेंट जो असेल तो रिमूव्ह होईल. इट विल जस्ट श्रिंक. ओके, दॅट कॉन्क्रीट इन्ग्रेडियंट्स विल श्रिंक टुगेदर. Okay, that is nothing but the shrinkage. Again, the second picture you can see here. Due to the shrinkage, these cracks are developed. You can see the gap. Okay. Next picture. Again, this transverse cracks you are going to see. These are again due to the shrinkage. Okay, and that is why to avoid the shrinkage in a concrete structure, you are going to provide the joints. Okay. In case of rigid pavements also, in case of your roads also, in case of our buildings also. Okay, we are providing the joints. It may be the contraction joint, it may be the expansion joint. It depends on this type of the weather conditions and the design. Okay, now which factors which are affect this particular shrink? The factors affecting the shrink we are going to discuss. First is the drying condition. Second factor, time. Third one, water is to cement ratio. Okay, now we will discuss one by one all these factors. First is drying condition. The most important factor is the drying condition or the humidity in the atmosphere. No shrinkage will occur if the concrete is placed in 100% relative humidity. Okay, but it is not, I can say, feasible or possible to have the 100% relative humidity. Okay, that is why again I am repeating my sentence. Whenever we are dealing some work associated with the concrete, maybe the concrete casting is there and all that in concrete technology, it is recommended to use the AC system, that is air conditioning system. Okay, why? Because with the help of the air conditioning system, we can maintain the temperature of that room. Obviously, we are going to maintain. If the room temperature is maintained, the temperature of the concrete body also we are going to maintain. Maybe some standard temperature like 25 to 27 degrees centigrade. Along with that, we can control the relative humidity also. Okay, we can fix the relative humidity which is more than 60% or 65%, whichever is there for that particular concrete structure. Okay. So if you are using some AC system in the concrete labs, you can do so. No shrinkage will occur. तुमच्या concrete मध्ये shrinkage होणार नाही if the concrete is been placed in 100% relative humidity. Not possible. Now let's just take this example. Okay, the example of one bridge is constructed on the water. Correct? This bridge is constructed on the water. Now if you are going to see some part of this bridge, maybe this portion, bottom portion, some part of this portion is in the water and some part is above the water surface. Correct? If you just take this part, some part is below the water, some concrete part is below the water and some part is above the water. So these are very dangerous structures. Either you kept it in full open dry condition or you kept it in fully covered with the water. But these conditions are very critical for us in our design also. Okay, because some part, the same column is there, column is same, half portion of the column is in the water for a constant duration, okay, maybe for 10 years, 15 years, 20 years, and half portion of the column is in drying condition. So half portion is directly exposed to the sunlight which is acting on it, sun rays are directly dropping on that half portion, and remaining half portion is in the water for a long duration. So in such critical cases, it is very important for us to have the proper design of such structures to maintain the humidity, in that particular structures. Okay. Otherwise, what will happen due to such critical conditions? It may happen that there will be shrinkage. There will be shrinkage, that is change in the volume. Okay. Second factor is the time. So the shrinkage rate will decrease rapidly with the time. It is documented that the 14 to 34%, 14 to 34% of 20 years shrinkage will occur within 2 weeks of it being when it is going to be placed in the structures. जे बघा 20 वर्षामध्ये जे काही श्रिंकेज ऑकर होणार आहे, ह्या 20 वर्षांमध्ये जे काही टोटल श्रिंकेज ऑकर होणार आहे, जे काही त्याची क्वांटिटी असेल, त्यातलं 14 to 34%, 14 ते 34% श्रिंकेज पहिल्या 2च आठवड्यात ऑकर होतं तुमच्या कॉन्क्रीट बॉडीमध्ये. ज्यावेळेस तुम्ही हे कॉन्क्रीट कुठे पोर करणार आहात, एखाद्या स्ट्रक्चरमध्ये प्लेस करणार आहात, पहिल्या 2 वीक मध्येच त्यामध्ये तेवढं श्रिंकेज ऑकर होतं, आणि त्यानंतर जसा स्पॅन जातोय पुढे तसं ते श्रिंकेज ऑकर होईल. विदिन 1 year of concrete being poured, shrinkage will be about 66 to 85% of the total 20 years shrinkage. बघा, 1 वर्षामध्ये 65 ते 85% श्रिंकेज ऑकर होते तुमच्या कॉन्क्रीट बॉडीमध्ये. ठीक आहे, 1 वर्षामध्ये. बघा, श्रिंकेज इन द अर्ली फेज इट इज गोइंग टू डेव्हलप. ज्यावेळेस तुम्ही तुमचं बांधकाम पूर्ण करताय, बांधकाम पूर्ण केल्यानंतर पहिल्या 1 वर्षामध्ये जवळपास 80% श्रिंकेज ऑकर होणार तुमच्या कॉन्क्रीटमध्ये. कधी ऑकर होऊ शकतं? जर तुम्ही काही प्रॉपरली, जर इफ यू आर not executed work as per the plan, if you have done some malpractices, okay, if you are doing wrongly mixed proportion, your execution is wrong, then definitely shrinkage will goes on increasing very rapidly. Okay, but the shrinkage rate will decrease on the other hand with time also. Okay, means after 1 year span, after 2 year span, after 3 year span, okay, the rate of the shrinkage goes on decreasing. The rate of the shrinkage goes on decreasing. Okay, so this is the second factor which is going to affect shrinkage. Third factor is the water is to cement ratio. Third factor, water is to cement ratio. Now how it is going to affect? Just a minute. कर्टन्स ओपन करा, खिडकी ओपन करा, असं एकदम बंदिस्त ठेवले तुम्ही स्वतः. क्लोज करा. Not possible. No. When you are preparing your concrete mix, it is very important for us to maintain the humidity as well as the standard temperature of that concrete. Okay. On site, it is not feasible for us to provide the AC. Okay, but in the labs, definitely we can provide it. Okay, because the structure that you are going to build after its construction, maybe now I can give you the best example. If you go outside, I think exterior temperature is more than 30 degrees right now. Now you are sitting in the classroom. What is the temperature? Definitely it is less than that, because it has been covered or it has been protected with the walls. Correct? So once you are going to pour the concrete in the structure, it will get cured. At that moment only it will get cured. Correct? त्याचं क्युरिंग चालू होतं. ज्यावेळेस तुम्ही कॉन्क्रीट पोर करताय, क्युरिंग कशासाठी करतो? यासाठीच तर करतो ना. ठीक आहे. जरी टेम्परेचर 40+ असेल किंवा 40 डिग्री असेल, तरी सुद्धा तुम्ही कॉन्क्रीटला क्युअर करताय. कशाने क्युअर करताय? वॉटरनेच क्युअर करताय ना. मग वॉटरने क्युअर केल्यावरती टेम्परेचर काय होणार आहे? ऑब्विसली कमी होणार किंवा ते त्या टेम्परेचर मध्ये राहतं. ठीक आहे, त्या पद्धतीने हे एक्झिक्युशन असतं. No, for curing, you can use any of the material. It may be the water compound, or it may be some curing compounds which are available in the market, or you can use water also. No problem. Curing compounds are also there in the market right now. Okay, but again, your what can I say? Cost of construction goes on increase if you are using some curing compounds. If water is available with you, then you can use it with the water. Okay, if it is available. If it is not available, like for the big structures, they are going to cure that particular structure with the different techniques. Like membrane curing is there, then gunny bags are there. Wet gunny bags we are going to spread it. रोड मध्ये बघितलं असेल आपण, वेट गनी बॅग स्प्रेड करतो रोडवरती रिजिड पेमेंटला. ठीक आहे, क्युरिंग साठी. त्यानंतर तुमचं मेम्ब्रेन क्युरिंग आहे किंवा हे क्युरिंग कंपाऊंड्स तुम्ही वापरू शकता. ठीक आहे, आता क्युरिंग कंपाऊंड्स मध्ये थोडंसं ऍडिशनली सांगतो. वी आर हॅव्हिंग सम वॉटर ऍब्सॉर्बिंग एजंट्स. काय आपल्याकडे ऍडमिक्सचर्स आहेत आणि ऍडमिक्सचर मध्ये एक वॉटर ऍब्सॉर्बिंग एजंट सुद्धा आहे. ठीक आहे, व्हॉट दे विल डू, they will absorb the water or the moisture which is present in the atmosphere, and with the help of that they can त्यांना क्युरिंग करण्याची गरज पडत नाही असं स्ट्रक्चरला. Self they are going to absorb the moisture or the water from the atmosphere and selfly they get cured. We are not going to pour it in the water and we are covering it. असं होत नाही, असे पण स्ट्रक्चर आहेत आपल्याकडे. ठीक आहे, so it's better if you have water available in the abundant quantity, you can use it that for the curing of the your structure. If the water is not available, some problem is there, maybe some scarcity of the water, then you can go for the other alternatives. Otherwise don't do it. The next factor is nothing but the water is to cement ratio. Okay, the factor which is going to affect this shrinkage. The water to cement ratio will influence the amount of shrinkage that occurs. The concrete's richness also affects this shrinkage. The process of swelling and then drying affects the concrete integrity and the shrinkage. Okay, how the water cement ratio is responsible, or how it is playing the role in the shrinkage. As I told you previously also, if you are going to use very less water, if you are going to use very less water cement ratio, then that concrete is little bit dry. The workability is absolutely zero. It's a harsh concrete you are having. Okay, if you are using very less quantity of the water. Okay, that concrete again, once there is a change in the temperature or due to the action of the weather, some water may get evaporated from that concrete body itself when temperature rises. Now, if you have used very less water cement ratio, and if temperature goes on increasing, what will happen? It will start shrinking. It will start shrinking, and then you are going to see some failures like honeycombing is there, some cracks which are being developed. Okay, that is why it is important for us to select the exact water is to cement ratio in our concrete structure. It is very important for us to select the proper water is to cement ratio. Okay, because if you use very less water cement ratio, it will prone to going to happen this shrinkage very early. Okay, at the earliest stage. But if you take the exact amount of water is to cement ratio, then definitely it will reduce the intensity of the shrinkage as much as possible. Okay, so shrinkage will affect the concrete richness. Richness is means its workability or the ease with which we can place it. Okay, the process of swelling and then drying. Now, in winter or during the rainy season, what will happen? If there is a heavy rainfall, definitely your concrete structure will going to absorb some water. Okay, in rainy season, it will going to absorb the water, or maybe there is a heavy snowfall and some moisture has been absorbed or some water has been absorbed by that concrete structure. असं होतं जे तुम्ही घरामध्ये बघत असता, तुमच्या घराला कुठेतरी पॅचेस दिसतात वॉटरचे. ठीक आहे, हे पॅचेस दिसतात म्हणजे काय? the moisture is get entrapped or the water is get entrapped, locked in that concrete body itself. It may be that concrete body has absorbed that particular water or it has absorbed that particular moisture. Okay. Now this is about the rainy season. That is, there will be the swelling. Huh? But after that, maybe after the rainfall, the temperature goes up to more than 40 degrees centigrade. Okay. In summer season, the temperature goes on increase. So what happened? Due to the rise in the temperature, the water gets evaporated from the concrete body. So absorption of the water from the concrete in the concrete body and evaporation of the water from the concrete body. Due to this process, again, it will affect the shrinkage. Okay, it will help to have the shrinkage. Alternate swelling and drying, or the drying effect, it will affect the concrete integrity, it will affect the performance of your concrete body, and then it may lead to the shrinkage. Okay, so this is all about the factors which are affecting the shrinkage. If you have any doubt regarding this factors affecting the shrinkage, please let me know. समझले हैं बात? Okay, online.
Yes, sir.
Kalpesh Chavan.
Yes, sir.
Yes, sir.
Okay. Now let us proceed. काय म्हटलं? We can, I can say, it is absolutely in our hand also to have the good quality of the concrete for the execution. But we can't control the creep which is going to happen in the concrete body. Creep is nothing but the deformation. And why it is going to happen? It is going to happen due to the load which is acting on the body for a longer duration. Maybe your structure lasts long for 10 years, 20 years, 30 years. So as the age proceeds, as the age goes on increasing, there will be some deformation. Okay. So I think though I don't have, maybe we can't have the control on the creep, but, and it is not like that. If in the early stage, means you have constructed a home and within 2 months you have seen, you are going to see some cracks which have been developed. That is not the creep. It's a big deformation. Okay. It is maybe due to the faulty execution work and all that. The results are different for that case. Creep is a permanent deformation which is with respect to the time. As the age of the concrete proceeds, there is a deformation internally. मी तुम्हाला खूप सोपं उदाहरण सांगितलं होतं. At the age of 5, at the age of 10 years, at the age of 20 years, up to 20 years, maybe. Okay. We are young, dynamic, we are having more energy, we are having more response to the diseases. Immunity, we are having very good. But as the age proceeds, what will happen? At the age of 30, the bone density starts decreasing. Maybe at the age of 40, our hairs get whiter. Okay. Color of the hair goes on changing. Okay. So this is nothing but again the type of deformation with respect to the age. Okay. Whether we are having the same immunity at the age of 80, right now, if I am 32 years old, I will, whether I am having the same immunity as that of at the age of 80, no. Probably not. Okay, because as the age proceeds, there is a, due to some regular exercise, due to this exertion and all that, our body needs rest, and if it is not going, if it is not getting properly, then our body also starts deforming. Okay. Maybe as I told you, we are having some deficiency of the vitamins. Okay, we feel sick. Then maybe with respect to the age, the bone density goes on decreasing, and there are so many. Likewise, in our concrete also, deformation goes on. Okay, with respect to the age, or as the age proceeds, there may be chances of the deformation of the concrete wall. Not at the early stage. That is why our concrete structure is going to stand a life of at least 50 years. Okay. Now it is up to us only whether we are actually executing our work as per the design, whether we are maintaining the quality and the quantity of our work. Okay. If you are going to maintain it, definitely we can achieve it. Otherwise, no. You are going to see the deformation at very early stage, maybe after 10 years, 20 years. Now, next part of our this particular chapter is nothing but the shrinkage and the types of this shrinkage. There are 4 different types of this shrinkage which we are going to study in this particular chapter. Okay, let us discuss the different types one by one. First type of the shrinkage is the plastic shrinkage. Second type is the drying shrinkage. Third type autogenous, and fourth one is nothing but your carbonation shrinkage. Okay. These are the 4 different types of the shrinkage, and in your online MCQ examination, definitely you will have the question on this shrinkage. Okay, maybe on the types of the shrinkage. What is the plastic shrinkage? Define it. You are having 4 options. Definition of drying shrinkage will be there, and you have to argue the answer for the correct one. Okay, so only definitions are there, not a descriptive part that much at this particular stage. So let us start discussing the different types of shrinkage. First one, plastic shrinkage. The plastic shrinkage happens soon after the concrete is poured in the form. Thermal shrinkage is not the type which is occurred in the concrete. Okay, the stresses are there. We called it as the thermal stresses. These are different in case of our road pavement. Okay, so let us discuss the first type, plastic shrinkage. Plastic shrinkage happens soon after the concrete is poured in the form. So immediately once you are going to pour the concrete in the concrete structure, maybe तुम्ही नवीन बांधकाम करायला घेतले आणि एखाद्या सपोज बीम मध्ये तुम्ही कॉन्क्रीटिंग केलंय. So immediately after pouring the concrete in the structure, you are going to see the plastic shrinkage. What is going to happen actually? The water evaporates and results in the reduction of the volume. The water evaporates and results in the reduction of the volume. This causes the concrete on the surface to the collapse. This causes the concrete on the surface to collapse. So the aggregate particles or the reinforcements come in the way of the subsidence, due to which the cracks may appear at the surface and internally around your aggregates or the reinforcement. Okay, so what is actually going to happen in case of the plastic shrinkage? कधी occur होतो हे आधी लक्षात घ्या. You have decided to start the construction of the building, and as you have started your project, one day you are going to fill the concrete in a column, or it may be the beam. Okay, it may be the beam. Just a minute, dear students. So coming back to our point of discussion, now you have started your own project, and one day you are just filling the concrete in maybe column, beam, or slab. It may be any structural element. So immediately after pouring the concrete in the structure, in your structural element, what happens? Maybe due to rise in the temperature, the water starts evaporating from the concrete body itself. The water starts evaporating from the concrete body itself, and this causes the concrete on the surface to collapse. काय होतंय? ज्यावेळेस वॉटर इव्हॅपोरेशन चालू होतं तुमच्या कॉन्क्रीट बॉडीमध्ये, जो टॉप सरफेस असतो, जो वरचा भाग असतो, ठीक आहे, फक्त वरचा भाग कॉन्क्रीटचा. आता कॉन्क्रीट काय रे, तुम्ही एका बीम मध्ये कॉन्क्रीटिंग करत होता, ठीक आहे. आता बीम मध्ये तुम्ही ऑलरेडी त्याला फोमवर्क प्रोव्हाइड केलेला आहे, बरोबर आहे. हा, आणि त्या साच्यामध्ये तुम्ही त्या बीमच्या साच्यामध्ये तुम्ही कॉन्क्रीट भरता, ठीक आहे. बॉटम पोर्शनला काय होतं का नाही, ज्यावेळेस तुम्ही हा प्लास्टिक श्रिंकेज म्हणजे काय होतं, ज्यावेळेस तुम्ही कॉन्क्रीट इमिजिएटली पोर केले आणि इमिजिएटली पोर केल्यानंतर वॉटर स्टार्ट्स इव्हॅपोरेटिंग. तुम्ही सकाळी कॉन्क्रीटिंग भरलं होतं, सकाळी भरले तुम्ही, तो बीम भरलाय, आणि दुपारनंतर टेम्परेचर थोडंसं वाढलेलं आहे, मे बी अराउंड 40 डिग्री सेंटीग्रेड टेम्परेचर आहे. द वॉटर स्टार्ट्स इव्हॅपोरेटेड फ्रॉम द टॉप बॉडी ऑफ दॅट कॉन्क्रीट. जो काही तुमचा बीम असेल त्या बीमच्या टॉप पोर्शन मधनं वॉटर स्टार्ट्स इव्हॅपोरेटेड. काय होत आहे, टॉप पोर्शन पासून वॉटर स्टार्ट्स इव्हॅपोरेटेड, अँड बिकॉज ऑफ दिस early cracks you are going to see. You are going to see the early cracks on the top surface of your concrete. Okay, and that is nothing but the plastic shrinkage. Okay, that is nothing but the plastic shrinkage. Hope you understand this. समजलंय? What is the reasons for happening of this plastic shrinkage? High water is to cement ratio, badly proportioned concrete, rapid drying, greater bleeding, or unintended vibrations are the some of the reasons for the plastic shrinkage. Okay. Plastic shrinkage can be reduced mainly by preventing the rapid loss of water from the surface. It can be reduced by covering the surface with the polyethylene sheet immediately after when it is been poured in the concrete structure. Okay. So you can just protect it. This is one example of the plastic shrinkage. You can see the cracks are developed only at the top. On this top surface of this concrete body, crack is being developed. Can you tell me what will be the depth of this crack? We can't predict it. Okay. We can't predict actually the depth of that particular crack. It may be up to the reinforcement. It may be up to just 1 or 2 mm. It may be just 1 inch, half inch. Okay, whatever it may be, we can't predict. So how can we predict, sir? This will be the depth of this crack. Do you have some instruments? Yes. In non-destructive testings, now we are having some modern equipments which can locate your reinforcement, like river locator are there. Okay, and some instruments are there which can identify what will be the exact depth of that particular crack, so that you can take immediate action against that particular crack. Up to this point, our construction field has what can I say, modernized. Okay, we are having very latest, very good equipments which will predict the life. Maybe you are using some non-destructive testing equipments for the same. Okay. Plastic shrinkage कशामुळे ऑकर होणार आहे सांगू शकता परत एकदा कुणी? Maybe you can put your answer in the chat box. कशामुळे plastic shrinkage होतोय? What is the reason? Evaporation from the top surface of the concrete body. It is very important. Evaporation from the top surface only. And when it is in fresh condition, plastic condition, okay, at the early stage, you have just poured the concrete in the concrete body, in the foam wall, and immediately after that, you have seen the water start evaporated from the top surface, and there is a formation of the early cracks. Okay, plastic shrinkage. I hope everyone has understood. समझला plastic shrinkage?
Yes, sir.
Early cracks you are going to see. Second part, or the second type of shrinkage, is nothing but the drying shrinkage. Now, what is the drying shrinkage? Let us discuss in detail. Just as the hydration of cement is an everlasting process, the drying shrinkage also is an everlasting process when the concrete is subjected to the drying conditions. When your concrete is subjected to the drying conditions, then definitely you are going to see the drying shrinkage. Okay. The loss of free water contained in the hardened concrete does not result in any appreciable dimension change. It is the loss of water which is held in the gel spores that cause the change in the volume. Okay. So under the drying condition, the gel water is lost progressively over the long time, and as long as the concrete is kept in the drying condition. The magnitude of the drying condition is also the function of the fineness of the gel. So finer the gel, more will be the shrinkage. It has been pointed out that the high pressure steam cured concrete with low specific surface of the gel shrinks much less than that of your normally cured cement gel. So this is the example of the drying shrinkage. Okay, I hope you understand. समजलंय? ठीक आहे, नुसतं वाचून दाखवलं ना, त्यामुळे समजलं असतं. चला एक्सप्लेन करूया आता. फक्त वाचून बघितलं आता आपण काय होतं नेमकं कॉन्क्रीट बॉडी मध्ये. ठीक आहे. See, when you are going to cure the concrete, as we know, there is a heat of hydration process, correct? Which is going to happen in the concrete body. Actually, cement is that particular ingredient in which that heat of hydration process is there. Okay, it is not there in your coarse aggregate or in your fine aggregate, correct? It is there only in your cement. Okay, what is heat of hydration? Heat is been liberated from that concrete body. Very simple. There is formation of the CHS gel and all that. So heat is being liberated during this process. So as heat is being liberated, it's a continuous and long lasting process. Everyone knows it. And along with that, there is a drying shrinkage which is also going to happen for if you are going to keep your concrete in the drying conditions. आता ड्राइंग कंडिशन म्हणजे नेमकं काय होतं? So there is a loss of water. There is a loss of water, not from the particular hardened concrete. Okay, not from the particular hardened concrete, but it is from the water which has been held or which has been present in the gel spores. आता सगळ्यांना माहिती आहे आपल्या कॉन्क्रीट मध्ये सुद्धा काही वॉइड्स असतात, बरोबर आहे ना? आपण कॉन्क्रीट मिक्स डिझाइन मध्ये ते शिकणार आहोत की पर्सेंटेज ऑफ एअर कंटेंट जे असतं ना, एअर वॉइड्स जे असतात, एअर कंटेंट, if you are using a 20 mm size coarse aggregate, the percentage of air content is 1%. If you are using 10 mm, I think it is less than that. And if you are using 40 mm size coarse aggregate, the air content is around 2%. Okay? So in your concrete, definitely there are some gel pores आहेत. ठीक आहे, आपण जेल स्पोर्स कशाशी रिलेट केलेले होते रे? एक मी तुम्हाला रेशो सांगितला होता बघा, जेल स्पोर रेशो, बरोबर आहे? जेल स्पेस रेशो. In your chapter number 4, we have discussed that part. Gel space ratio. Can you define that word? आठवतंय कुणाला? What is gel space ratio? अभ्यासाला सुरुवात केली असेल तर 100% आठवण. आदित्य सांगते.
Volume of gel.
बर, ऑनलाइन मध्ये कुणाला सांगता येईल का? What is a gel space ratio?
Volume of gel divided.
विश्वजीत भूसनार, रोहन लोहार, संदीप पवार, किरण सातपुते. Somebody will please respond me. I will give you 2 minutes. I will give you. What is the gel space ratio? Volume of gel to the space available. Not correct definition. I want the correct or the exact definition. Take 2 minutes to search it. What is gel space ratio? I have given you 2 minutes to search the definition. Ratio of volume of cement gel to the sum of volume of the cement gel. Ratio of volume of cement gel to the sum of volume of the cement gel and the capillary pores. Okay. It is the volume of the hydrated cement paste to the sum of volume of hydrated cement paste and the capillary pores. Yes, correct. I think everybody has given the answer now. It is the ratio of the volume of the hydrated cement paste to the sum of volume of hydrated cement paste plus capillary pores. Okay. Chalo, good. I'm happy you are responding. So, in your concrete is going to have some voids within that body, concrete body, correct? I think everybody will agree with me. As we are having some air content, okay, definitely there are some voids in the concrete body itself. Whether it is visible to us Definitely not. Okay. Very small micropores are there. Very small. Very small micropores are there. Okay. And what happened in the drying shrinkage due to the change in the weather conditions? Okay. There is a loss of water from that walls, or from that gel spores. Okay. If the water is being evaporated from the gel spores, what will happen? There is a loss of water. If there is a loss of water from the gel spores is going to happen, there is a change in the volume of the given concrete. Definitely. Okay. So that is nothing but the drying shrinkage. In drying shrinkage, there is a loss of water, definitely. But from which point there is a loss of water? There is a loss of water from the gel spores. ओके, त्या कॉन्क्रीटच्या बॉडीमध्ये जे काही व्हेरी मायक्रो स्पोर्स असणार आहेत, जेल स्पोर जे ऑक्युपाय होणार आहेत सिमेंट आणि वॉटर पार्टिकलनी, ठीक आहे, दॅट फ्रॉम दॅट पोर्स द वॉटर इज गेट इव्हॅपोरेटेड and that is nothing but the drying shrinkage. It is going to because of there is a evaporation of the water, it leads to the drying shrinkage. Okay, so under the drying shrinkage, the gel water is lost progressively over a long time as long as the concrete is kept in drying condition. So if you are going to keep the concrete in the drying condition for the very much long time, maybe you can take the example of your bridges, okay, or maybe the any maybe the rigid pavement, you can take the example. Okay, these are most of the time these are exposed to the direct sunlight. These are being kept in the drying condition for a long duration. Unless and until there is no rainfall once in a year, they are in the drying condition, or maybe in winter they will absorb some moisture. But apart from that, they are in drying condition. Okay, so if your concrete structure is in the drying condition for a longer duration, the water from the gel spore starts evaporating. The water from that gel spore starts evaporating, and it may lead to the drying shrinkage. Okay, so the magnitude of drying shrinkage is also the function of fineness of gel. Very important. Finer the gel, more will be the shrinkage. Okay, so that where whatever the gel openings are there or the gel spores are there, these are not should be more finer. Okay, actually खूप कमी पर्सेंटेज असलं पाहिजे जेल स्पोर्स किंवा जे काही मायक्रोस्पोर्स आहेत ना प्रेझेंट बॉडीमध्ये. ठीक आहे, मी तर म्हणाल 1% काय 0.5% पेक्षा कमी पाहिजे एअर कंटेंटचं पर्सेंटेज. ठीक आहे. So the picture already I have shown it to you. See some whatever the micropores are there which are present on that concrete surface, the water from that pores has evaporated, and you are going to see the drying shrinkage. There is a change in the volume of this concrete structure. Okay, this is another one. You have seen this. अजून ड्राइंग श्रिंकेज जर बघायचं असेल ना, किंवा श्रिंकेज हा जर प्रकार तुम्हाला ऑब्झर्व करायचा असेल ना, आपल्या एक अंडरस्टँडिंग साठी उदाहरण देतो मी तुम्हाला. अंडरस्टँडिंग साठी आपल्या शेतीमध्ये छानपैकी अशी काळी जमीन असते, ब्लॅक कॉटन सॉइल ज्याला म्हणतो, बरोबर आहे. त्याच्यामध्ये पाणी टाकल्यानंतर चिखल होतो, बरोबर आहे. आणि त्यानंतर तुम्ही पाणी टाकल्यानंतर चिखल झालाय, सगळं काही झालंय, तुम्ही नंतर इट इज एक्सपोज टू द डायरेक्ट सनलाइट फॉर ऍटलीस्ट 3-4 days, 3 ते 4 दिवस तसंच आहे. त्याच्यामध्ये पाणी नाही, काय नाही, काय बघितलं रे तुम्ही त्या मातीला? अशीच ढेकळं पाहतात ना, अशा पद्धतीचे क्रॅक्स बघितले जे तुमच्या स्क्रीनवरती पाहताय तुम्ही. त्याच्यामुळे हे झालं रे असं. This is nothing but the shrinkage. Water has evaporated from the concrete, from that soil, and you are going to see such shrinkage. So in the same fashion, in the same way, the shrinkage is going to appear in our concrete structure also. बघितलं ना अशा सरफेस शेतीमध्ये? ठीक आहे. I think everybody has seen this. Same in the concrete structure. This is another one. Let us proceed for the next type of the shrinkage, autogenous shrinkage. Okay, so in conservative system, what is the conservative system? At first we will discuss it. I will read at first and then we will explain. I will explain. In the conservative system, that is where no moisture movement to or from the particular paste is permitted, that is the moisture movement is entrapped, it is locked in the concrete body. When the temperature is constant some shrinkage may occur. The shrinkage of such conservative system, we called it as the autogenous shrinkage. We called it as the autogenous shrinkage. So autogenous shrinkage is of minor importance and is not applicable in practice to many of the situations except the mass of the concrete in the interior of the concrete dam. Okay. Here you are going to see the autogenous shrinkage. नेमकं काय म्हणते autogenous shrinkage म्हणजे conservative system म्हणजे काय असतं म्हणजे in your concrete there is a moisture, presence of moisture. Everyone will agree with me. There is 100% presence of moisture. The presence of moisture may be 1%, 2%, 3.5% maximum. It may be anything. Okay, up to 3% it has been there. Okay. In some cases, it may be differ from this 3%. Okay, so generally, your fine aggregates or your coarse aggregate, they are having some moisture content. Okay, your concrete body is having some moisture content within that concrete. So we know there is a moisture which is present in the concrete. Sometimes what happens? There is no movement of this moisture within the concrete body. Moisture is there, but it is been occupied or it is been locked in one place only. There is no movement of that moisture within the concrete body, though there is a constant temperature. Sometimes you are going to see such structures. Water is also locked. ठीक आहे, तुम्ही घरामध्ये बघता पॅचेस पडलेले असतात. का बरं पॅचेस पडलेले असतात आपल्या घरामध्ये ज्यावेळेस तुम्ही जास्त पाणी मारता? एकाच ठिकाणी पाणी तुम्हाला साचलेलं दिसतं. पाणी म्हणजे काय, तो पॅच दिसतो एकाच ठिकाणी. काय होतं रे, पूर्ण वॉल मध्ये तुमच्या तुम्ही वॉटर स्प्रिंकल केलेलं होतं पण एकाच ठिकाणी वॉटर ऍब्सॉर्ब झालं. काय होतं अशा वेळेस, ते वॉटर जे आहे किंवा त्याचे मॉइश्चर आहे ते त्याच ठिकाणी लॉक झालं, एंट्रॅप झाले, त्याची मुवमेंट झाली नाही. एंट्रॅप एकाच ठिकाणी झालेलं. सो व्हेन देअर इज अ नो मुवमेंट, फ्री मुवमेंट ऑफ द मॉइश्चर, व्हॉट विल हॅपन, देअर इज अ श्रिंकेज विच इज गोइंग टू ऑकर. म्हणजे एका ठिकाणी पाणी आणि दुसऱ्या ठिकाणी ते ड्राय झालं. एका ठिकाणी पाणी लॉक झालंय आणि दुसऱ्या ठिकाणी ते ड्राय दिसतंय. सो इफ सच सिच्युएशन इज देअर, then that situation you called it, or in such situation the shrinkage which is going to happen in the concrete body, you called it as the autogenous shrinkage. Means the movement of the moisture is being locked at one place though there is a constant temperature. And if such thing is going to happen, there is some shrinkage which is going to be happen in the concrete body, and that shrinkage you called it as the autogenous shrinkage. Now where you are going to see such autogenous shrinkage? Interior part of your concrete dams, whatever the gravity dams we are having, where concrete is used. So the inner portion, interior part of your concrete. Why interior part? If you see the concrete dam on the left hand side, just on the downstream, on the upstream side of that particular dam, I think everybody is aware what is upstream side and what is downstream side. Okay, so on the upstream side, you are having the water, correct? The dam or that concrete body has been covered with the water only, correct? So on the upstream side, the concrete body has been covered with the your water, while on the downstream side, the concrete is directly exposed to the sunlight. The concrete body is directly exposed to the sunlight. See, on one hand, we are having exposed to the direct sunlight condition. On the other hand, we are having the concrete which is totally covered up with the water. So in such case, in the interior part of the concrete body of the dam, okay, there may be locking of the moisture movement. There may be locking of the moisture movement, and there you are going to see such autogenous shrinkage. Okay, there you are going to see such autogenous shrinkage, which is not good. Huh? That is why construction of these mass structures like dam and all other things are there. We are going to use the low heat cement. I think in your chapter number 1, I have told you that example. Okay, we are always preferring to use the low heat cement. Okay, in case of your mass constructions, in case of your mass concrete structures, because low heat cement heat of hydration process will be on the lower side. Okay, and there are less chances of occurrence of the cracks at the early stage, or maybe at the later stage also. Okay, maybe at the later stage also. because this mass structures, maybe you can take the example of pier of a bridge. जर बीचचा जर तुम्ही पियर बघताल, पियरचा हाफ पोर्शन हा वॉटर मध्ये असतो आणि हाफ पोर्शन हा डायरेक्टली एक्सपोज टू द सनलाइट असतो. असे स्ट्रक्चर डिटोरिएट होण्याचे किंवा डिफॉर्म होण्याचे खूप जास्त चान्सेस असतात ॲट द अर्ली स्टेज. आणि इफ यू आर नॉट गोइंग टू एक्झिक्यूट सच वर्क with very much of preciseness, which very much of accuracy by maintaining the good quality in the construction, then definitely you are going to face the deterioration, deformation, shrinkage, creep, whatever the causes of the failure. Okay, at very early stage. So to avoid that, try to maintain the quality in your construction. Okay, I hope now heterogeneous shrinkage also you have understood very well. What is the heterogeneous shrinkage at all? लक्षात ठेवायचं, प्लास्टिक श्रिंकेज मध्ये टॉप सरफेस वॉटर इज बीन इव्हॅपोरेटेड फ्रॉम द टॉप सरफेस अँड क्रॅक्स आर डेव्हलप्ड ॲट द टॉप सरफेस. ड्राइंग श्रिंकेज, the water from the gel spores has been lost. In heterogeneous shrinkage, there is no free movement of the moisture. Okay, and last but not the least, we will discuss the carbonation shrinkage. Okay, now what is the carbonation shrinkage? So carbonation shrinkage is a phenomenon very recently recognized and is very important. Carbon dioxide present in the atmosphere, carbon dioxide present in the atmosphere, that is your CO2, reacts with the presence of water in the hydrated cement. Reacts in the presence of water with the hydrated cement. So calcium hydroxide gets converted, that is CaOH taken to us. Calcium hydroxide gets converted into calcium carbonate, and also some other cement compounds are get decomposed during this reaction. So such a complete decomposition of the calcium compound in the hydrated cement is chemically possible even at low pressure of the carbon dioxide in the normal atmosphere. So the carbonation penetration beyond the exposed surface of the concrete is only very slow. The rate of penetration of the carbon dioxide depends upon the moisture content of the concrete and the relative humidity of the ambient medium. Okay. Now carbonation is accompanied by an increase in the weight of the concrete and by the shrinkage. Okay. Carbonation shrinkage probably caused by the dissolution of the crystals of the calcium hydroxide and deposition of the calcium carbonate in its place. As a new product, as this new product is less in volume, that can be that product is replaced, the shrinkage takes place. Here you can see some carbonation shrinkage is there. Okay, what is actually going to happen? I will explain it. Don't worry. Effects we will discuss it later. What is actually going to happen? Everyone knows we are having the heat of hydration process which is going to happen in our concrete body. बघा आपल्या concrete मध्ये heat of hydration process होते सगळ्यांना माहिती. During this process, it may happen that the CO2 which is present in the atmosphere, will react with the hydrated cement. And due to this reaction, what will happen? Your CaOH, that is calcium hydroxide, that is the product of your CHSL and the heat of hydration process. Okay, your calcium hydroxide is get converted into the calcium carbonate, that is CaCO3. Okay, and because of this reaction, some compounds which are been present in your concrete body gets decomposed. And due to this decomposition, complete decomposition of your calcium compounds in the hydrated cement, there is a chance of the shrinkage which is going to happen, and that shrinkage you are going to call it as the carbonation shrinkage. Once again, I will repeat for everyone in Marathi. What is the carbonation shrinkage? ज्यावेळेस आपल्या कॉन्क्रीट बॉडी मध्ये हीट ऑफ हायड्रेशन प्रोसेस होत असते, ठीक आहे, ज्यावेळेस आपल्या कॉन्क्रीट बॉडी मध्ये हीट ऑफ हायड्रेशन प्रोसेस होत असते त्यावेळेस आपल्या ऍटमॉस्फिअर मध्ये प्रेझेंट असलेला जो CO2 आहे, ठीक आहे, that CO2 will react with the hydrated cement. त्याची रिएक्शन होणार आहे तुमच्या हायड्रेटेड सिमेंट मध्ये, आणि बिकॉज ऑफ दिस रिएक्शन द कॅल्शियम हायड्रॉक्साईड जो तुमच्या हीट ऑफ हायड्रेशन प्रोसेस मधला एक महत्त्वाचा पार्ट आहे, The calcium hydroxide is been converted into calcium carbonate. The calcium hydroxide is been converted into calcium carbonate, and there is a decomposition. There is a decomposition of your other compounds. Okay. So that due to this decomposition, there is a reduction in the volume of your concrete, and that particular shrinkage, you called it as the carbonation shrinkage. You called it as a carbonation shrinkage. Please remember this. What is the carbonation shrinkage? Okay. So the free CO2, the CO2 which is present in the atmosphere will react with the hydrated cement. The calcium hydroxide is get converted into calcium carbonate, and because of this, during this reaction, there is a complete decomposition of your calcium compounds, and because of that, there is a reduction in the volume of the, or there is a change in the volume of the concrete. It leads to the carbonation shrinkage. याला म्हटलं जातं carbonation shrinkage. समजलंय सगळ्यांना? What is carbonation shrinkage? आदित्य, ठीक आहे. Online समजलंय सर्वांना? Please do respond yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
संदीप पवार, किरण सातपुते, गणेश वाघमारे, रुपेश पडवे, विजय राठोड, सुमिता पंडित, मानसी कराळे,
sir.
गोमी. Okay, so these are the 4 types of this shrinkage. Please remember, handouts तयार करा. What is plastic shrinkage? Plastic shrinkage is going to happen at the top surface due to evaporation of the water from the top surface. Early cracks are developed. Drying shrinkage, loss of water from the gel spores. Autogenous shrinkage, there is a locking of free moisture movement. Okay. Then carbonation shrinkage, due to reaction of CO2 with your hydrated cement, there is a decomposition of your calcium compounds. Okay. And due to which there is a reduction in the volume, that is nothing but your carbonation shrinkage. So please remember all these 4 types of this shrinkage. Okay, now let us discuss few effects of this shrinkage, though this is not the part of your syllabus, but still additionally I will tell. Thermal shrinkage. What is the thermal shrinkage? Please explain. See, again I am repeating, this is not the thermal shrinkage taken. It's a thermal stress which has been induced in your concrete body, and this is due to the temperature conditions, variation in the temperature condition. What will happen? Hey, warping stress and thermal stress असे 2 स्ट्रेस असतात कॉन्क्रीट बॉडी मध्ये. ज्यावेळेस तुमचं कॉन्क्रीट स्ट्रक्चर it has been exposed to the sunlight. Okay, what is actually going to happen? Okay, just a minute. If you just take the example of the roads, okay, रोड बद्दल थोडंसं सांगतो, कारण हे स्ट्रेसेस जास्तीत जास्त तुमच्या रोड कन्स्ट्रक्शन साइट वरती तुम्हाला बघायला मिळते. What will happen? Only the top surface of the road gets heated due to the sunlight. Only top surface, there is a change in the temperature of the top surface. तुमचा जो रोडचा टॉप सर्फेस आहे ना, PQC लेअर, फक्त PQC लेअर मध्येच तुम्हाला टेम्परेचर वाटतं, म्हणजे देयर इज अ चेंज इन द टेम्परेचर. जे काही सनरेज आहेत, जे काही सनलाइट आहे, इट इज बीन ऍब्सॉर्ब और इट इज बीन एंटर्ड ओनली at the top surface. Okay, and another case is that due to the variation in the temperature, the sunlight is there is a, whatever the temperature is there, that has been fully penetrated through the different layers of your subgrade soil up to the subgrade soil of your rigid pavement. Okay, so there is a change in the variation. There is a change in that what can I say, analysis of the pavements, rigid pavements, due to this varying temperatures. Okay, due to the varying temperatures, some stresses are being induced in the concrete body, and out of that stress, one stress is your warping stress, and second one is nothing but the thermal stress. Okay, फक्त टॉप सर्फेसच गरम होणे आणि पूर्ण बॉडी गरम होणे. ठीक आहे, फक्त टॉप सर्फेसच गरम होणे आणि पूर्ण बॉडी गरम होणे. याचा अजून एक एक्झाम्पल मी तुम्हाला सांगू शकतो. इन आवर डे टू डे लाईफ, जस्ट गिव्ह मी मिनिट, आय विल रिमेंबर दॅट अँड आय विल टेल यू. If you are going to hit some object, okay, maybe a steel plate is there, or maybe any utensils of your kitchen. Okay. If you are going to hit it, start hitting it at the early stage, very early stage, what you are going to observe? Maybe top surface or the top portion, or maybe the handle is not that much heated. Okay. Only the bottom portion start heating. Okay. And later on, you are going to see that whole utensil or that kitchen utensil is completely gets heated. Okay. Likewise, in our concrete also, initially the heat is get penetrated only at the top surface, and then later on it will penetrate through the concrete body. Okay. There you are going to see the stresses are being induced in the concrete structure, and that stresses are warping and thermal stresses. Okay. I will take this part maybe if I get the chance to teach you highway internal engineering in your third year. Okay. If I get the chance, definitely I will. So this is all about the different types of the shrinkage that you are going to observe. Okay. Now let us discuss some effects of the shrinkage. What are the effects of the shrinkage? Shrinkage of the concrete between the two movement joints causes the joints to open or makes it wider. रोड पेमेंटचं सेक्शन आहे ठीक आहे जॉइंट्स मध्ये काय होतंय श्रिंकेज ऑफ द कॉन्क्रीट बिकॉज ऑफ द श्रिंकेज ऑफ द कॉन्क्रीट the shrinkage of the concrete between the movement joints causes the joints to open म्हणजे हे जी joint width असते ना it may get expand or it may get or makes it wider. Therefore the joints must be designed to accommodate the widening caused by the shrinkage. Okay. Second, where other materials such as ceramic tiles that are fixed on the top of the concrete surface, the shrinkage of the concrete causes relative movement between the different materials. This resulting stresses that can cause failure at the interior interface. Okay, as I told you, some stresses are induced due to the varying temperature conditions, and it may lead to the failure of your concrete structure, maybe at the top or maybe at the interface. Then, if the shrinkage is restrained, the concrete is put into the tension, and when the tensile stress become equal to the tensile strength, the concrete cracks. Okay, so there may be cracks which are going to develop. Okay, then shrinkage of the concrete causes the concrete to grip the reinforcing bars more tightly. कारण श्रिंक होणार आहे ना बरोबर आहे की नाही आकुंचन पावतं म्हणजे काय रे त्या रेन्फोर्समेंटला ते अजून जास्त घट्ट पकडेल बरोबर आहे की नाही कॉन्क्रीट मध्ये काय आरसीसी मध्ये तुम्ही रेन्फोर्समेंट यूज करताय आणि जर ते श्रिंक झालं तर त्यामध्ये काय होणार आहे इट विल ग्रिप द रेन्फोर्सिंग बार मोर टाइटली and this increases the friction between the concrete and your reinforcement. It increases the friction between the concrete and your reinforcement, so it improves the bond strength especially for the plain bar. जिथे तुम्ही mild steel चा बार यूज करताय तिथे या पद्धतीने तुम्ही त्याची बॉन्ड स्ट्रेंथ इन्क्रीज करू शकता ठीक आहे पण maybe we have to take the ill effects also in our consideration ठीक है the deflection of your flexural members may be increased due to this shrinkage. Okay. Yes, you can see the dampen the subgrade preventions of this shrinkage. How we are going to prevent the shrinkage? Dampen the subgrade of the concrete before its placement, and it is liable to the water absorption, but should not over dam. Okay, like DPC course basically. आपण जो हे करतो तुमच्या बिल्डिंग मध्ये तुम्ही डीपीसी चा कोर्स बघितला असेल किंवा मे बी इन बीसीडी यू हॅव लर्न दिस टॉपिक व्हॉट इज डॅम प्रूफ कोर्स ओके यू हॅव टू ले डाउन द डॅम प्रूफ कोर्स at the bottom during your construction. Okay, why we are using this dam proof course? To avoid the entry of the water from the capillary pores. Okay, that is from the bottom ना ठीक आहे म्हणजे मला आठवतंय करेक्ट डीपीसी. Then next technique, try to start the curing soon after its finishing. Immediately after finishing, you must start the curing of the concrete compounds. Use of chemical admixtures to accelerate the setting time of your concrete. Okay. Conclusion of this particular chapter, I can say it as in order to avoid the negative impacts of the long-term creep and shrinkage. Okay. The conclusion of this particular chapter. The good understanding of the creep and shrinkage behaviors. I hope everybody is now aware about the concept of creep and shrinkage. What is creep? Which factors we need to consider in our creep? What is shrinkage? Which factors are affecting the shrinkage? What are the different types of the shrinkage? Then accurate estimation of the creep and shrinkage on the structural concrete design. Proper countermeasures for creep and shrinkage effects. Okay, thank you. Any questions in this particular chapter? Chapter number 5. So with that note, I declare that your chapter number 5 is finished. It's, I think, 440, 420, just 420. Okay, so we have finished our chapter number 5, and we are immediately going to start our chapter number 6, that is durability of the concrete. And hopefully, I think in next few days only, you will be matching with division A. Okay, right now their unit number 7 is going on, concrete mix design. So last 2 units are a little bit big. It will take some time just to have some examples of the concrete mix design. So maybe very soon you are going to match with them. Concrete mix design. Somebody says me thank you. Oh, thank you. But we are not going to stop here. Huh? Okay. Though you are telling me thank you, we are not going to stop. Okay. So we are directly proceeding towards our chapter number 6, that is durability of the concrete. Any questions in chapter number 5? Again, I am repeating. If you have any questions, please put it in the chat box. I will give you 2 minutes for question answering. Any questions? Anything that you are interested to discuss? कुठला पार्ट समजला नाहीये सर, हा परत एकदा रिपीट करा किंवा काय? Any question from your end? I will give you 2 minutes. Meanwhile, I will also take a short break. So we are going to start our unit number 6, that is durability of the concrete. And in this particular unit, what contents we are going to learn? The contents like minimum and maximum cement content, then strength and durability relationship, impact of water cement ratio on the durability, permeability, then exposure to the different conditions like sulfate attack, alkali aggregate reaction, chloride attack, and corrosion of steel. So all these parts we are going to discuss and how they are linked or how they are relating with the durability of the concrete. That is the part we are going to discuss. Okay. Minimum and maximum cement content. Where you have seen this part? Minimum and maximum cement content. In our IS 456-2000 table number 5, it will give you the idea about the minimum and maximum cement content, for different grades of the concrete. Then strength and durability. What is the strength at first? In our chapter number 4, I think I know everybody is not aware. I think everybody has forgotten the definition. What is strength?
To register load, sir. To register different types of load.
Ability to resist the stress
Different types.
without failure. Okay. Or load by area, whatever you think. Ability to resist the stress which is acting on an area of the concrete surface without failure. That is nothing but the strength. Okay. That is nothing but the strength. Now, second half, we are going to discuss durability. What is the durability and what is the relation between the strength and the durability? What is the impact of the water cement ratio on the strength and durability? What is permeability and how the concrete is been attacked by the different, maybe the sulfate attack or the alkali aggregate reaction is going to happen, or maybe the chloride attack. Okay, so all these parts we are going to discuss in our durability. आपण concrete मध्ये workability test conduct करतो, आपण सिमेंटचे टेस्ट कंडक्ट करतो, कोर्स ऍग्रीगेट, फाइन ऍग्रीगेटचे टेस्ट कंडक्ट करतो. का कंडक्ट करतो रे? Why we are conducting all these tests? Why we are testing our material? To assess their physical and the mechanical properties, to identify their suitability for the construction work. Correct? Because if these materials are not suitable for the construction purpose, whether we are going to use it in our construction work? No, definitely not. Because if you are going to use such material having the poor properties, then it may lead to the early collapse or early deformation of the structure. And this is the thing which we don't want. Okay, early collapse or the deformation. So what we want? We want our structure must have some strength, certain strength, the strength which is specified according to the different grades of the concrete, for which you are going to prepare your mixed design. And also, we are expecting certain durability. That means my structure will last long for at least 10 years, 20 years, 30 years. If you construct a flexible pavement, the design life is 10 to 12 years. I will give you one example. If you are interested to construct the flexible pavement, the life of that flexible pavement is at least 10 to 12 years. And what scenario you are going to see nowadays? Whether it will last long at least a year in a good condition? No. In case of rigid pavement, the structure of that or the service life of that rigid pavement is around 30 years. Okay, around 30 years. But again, you are going to see your structures get collapsed very early. Take the example of your building. Your RCC structures, they have the design life of at least 50 years. For 50 years, by considering the design life as 50 years, we are going to prepare the concrete mix and we are going to execute, we are going to prepare our design. But what scenario you are going to see? Whether your structure is that much durable? If you consider today's picture or today's scenario. I have the two answers for this. Definitely yes, this is my first answer. And no, this is the second answer. Why? Because from different regions, depending upon the mindset of the contractor or the engineer, whether he is going to follow all the legal practice of the construction as per the standard norms, we don't know. If he is going to do some malpractice in the concrete mix design, or maybe at the time of execution, maybe he has done some corruption in purchasing the raw material. Okay, poor quality raw material he has purchased, then we can't predict the structure will be durable. Okay, so depending upon, maybe some contractors or engineers, they are following legal practice, they are following all the design norms which are been specified as per our Indian standard, and their aim is to provide the durable structures or is to build the durable structures. Okay, ours also as an engineers, we should have that mindset to build the durable structure. Your structure at least last long for 30 years. I am saying at least 30 years. Okay, so try to have that habit of constructing good durable structures. Okay, now what is that durability? Let us discuss now the definition. Before proceeding that definition, let us have some introductory part about this part. So concrete, the man-made rock, most widely used construction material. Everyone knows. Concrete is the most widely used construction material. These are a little bit older digits you are going to see in the presentation. More than 80,000 crores cubic meter of concrete are poured in India every day. Okay. Not in the India, all over the globe. Okay. More than 80,000 crores of cubic meter of the concrete is being poured every year. And India has the capacity of more than 200 million tons of production of the cement. Okay, I think now that capacity has increased now. Okay, more than around 250 million tons of the cement we are going to produce. Okay, we know as far as cement manufacturing is considered, I think we are at the second position in the world. Okay, I don't know exactly, but we are at the second position as far as cement production is considered. Okay. Some structures are designed with a life of 100 years. Take the example of your dams. Dams are basically designed for a life of 100 years. Huh? No compromise in it. It is not like that after 10 years you are going to reconstruct the dam or you are going to regenerate the dam. Okay. Yes, second. Correct. So we are at the second position. So it is necessary that the concrete is which is used should be durable. How you are going to achieve the service life as you have designed it? Okay, for 10 years, maybe you have designed your structure for 50 years by assuming the design life of 50 years. How you are going to achieve it? If you are going to follow all the legal practice, you are going to achieve the good quality in your construction. Okay, proper execution is there, then it is possible for us to have the durable structure. So it is necessary for us that your concrete must be durable. Otherwise, your structure durability gets affected. So what is durability? इतके वेळेस आपण थोडंसं चर्चा करतो durability. What is that durability? Our key focus should be on this definition. Durability of the concrete is its ability. Durability of the concrete is its ability to resist the weathering action. To resist the weathering action from a chemical attack, abrasion, and any other process of deterioration. That is by the ACI. This definition is defined. Okay. So durability of the concrete is its ability to resist the weathering action. Okay. What is durability? Now, in most of the interviews, as a fresher, definitely they are going to ask you this question. Okay. I have the experience of, I think in one of my interview, that interviewer has asked me this question. Can you tell me what is the durability of the concrete? Because we are going to work on the site. We are going to prepare the structures. Correct? We are going to build the structures. And if you don't know the durability, what is the sense of building the structures? Okay. If you don't know the idea behind the durability term. So our key focus should be on the durability. And what is the durability? It is nothing but the ability to resist the weathering action, maybe the chemical attack, abrasion, and any other process of deterioration, which is going to happen in the concrete body. So ability to resist all these actions on the concrete body is nothing but the durability. Okay. In that word, ability word is there. Durability. Okay. So, you know, ability is nothing but capacity. Okay. What you can do, you can resist the weathering action. Your concrete should be such like it is going to resist all the weathering action, because if you consider our region, India, we are having 3 different seasons: summer season, winter season, and rainy season. So during these 3 different seasons, the temperature conditions are also going to vary. Correct? Starting from 10 degree, maybe we are expecting 40 degree also, maybe. Correct? Now, if you just take 2 or 3 days before, temperature of Mumbai, it is more than 35 degree. In the beginning of March only. Okay. April is ahead, May is ahead, but still in the beginning of March, the temperature is more than 35 degrees. Okay. So we are having different temperature conditions. So your concrete must able to resist all these temperature conditions. Your concrete must resist the chemical attack. Okay. Your concrete must resist any other deterioration which is going to happen in the concrete body. Okay. If it is having that ability to resist all this chemical action, chemical attack, weathering action, and any other process of deterioration, then you called it as a durability. Okay. Definition. Understood? Please remember this definition for the lifetime. Durability of concrete is nothing but its ability to resist the weathering action, okay, chemical attack, or any other process of deterioration. A durable concrete is one that performs satisfactorily in the working environment during its anticipated exposure condition during its service life, which has been given in our IS 456. I will show you that table also. Okay. Because your concrete is exposed to different conditions, environment conditions, like mild, severe, very severe, moderate, okay, and extreme. These are some levels of environmental exposure conditions. Mild means room standard temperature condition is there. Okay, moderate, maybe temperature is more than that. Your concrete is exposed to somewhat variation in the temperature. Then severe condition, affection of the temperature. So that table is given in our IS 456. I think table number, I just forgot that number, maybe in workability of concrete, that part is there. Okay, I will show you that table also. I will share, don't worry about it. Okay, so during different exposed, anticipated exposed conditions, during its service life, the concrete is withstand and it is performing satisfactorily. कधी उन्हाळा होता, कधी पावसाळा होता, कधी हेवी स्नोफॉल झालाय, सर अचानक टेम्परेचर 10 डिग्री पेक्षा कमी झालंय, अचानक टेम्परेचर 40 डिग्री पेक्षा जास्त झालेलं आहे, खूप हेवीली रेनफॉल झालेला आहे, कुठलीही एक्सपोज्ड कंडिशन असू द्या, your concrete has performed satisfactorily for achieving its service life, and that is nothing but we called it as a durable concrete. You have made the concrete in such a way that it is going to resist all these variations, all these attacks. Okay. So when exposed to the environment, durable concrete is likely to retain its original form, quality, and serviceability during its lifetime. Okay. That is all about the durability. I hope you have understand the definition now. What is durability of the product? Okay. The next things, consequences of improper quality and inadequate durability. काय होऊ शकतं जर तुम्ही durability achieve, if you are not going to achieve the adequate durability, what is going to happen? Or if you have followed improper quality, काय होऊ शकतं? There may be loss of strength of the concrete. Definitely, there will be loss of strength of the concrete. Second impact, concrete is liable to be easily affected by the deterrents. जे काही atmosphere मध्ये विषाणू असतील, जीवजंतू असतील, ठीक आहे, these are get easily, this will attack on your concrete body very easily. Then corrosion of the rebars, your rebars or whatever the reinforcement that you have used, it will get corroded very easily. Loss of serviceability, unpleasant appearance. कुठेतरी क्रॅक पडल्यासारखं खूप चांगलं दिसत नाही, खराब दिसतं. ठीक आहे, कुठेतरी हनी कॉम्बिंग दिसतंय मला. सो दॅट इज नथिंग बट अनप्लीझंट अपीअरन्स. घराचा कलरच उडलाय सर. अल्ट्रा एशियन पेंट वी हॅव यूज, इमल्शन काहीतरी भारीतला पेंट तुम्ही वापरला होता, ट्रॅक्टर इमल्शन पेंट अँड ऑल दॅट. बट व्हॉट यू आर गोइंग टू ऑब्झर्व, ओके, आफ्टर फ्यू इयर्स दॅट पेंट वॉज गेट व्हॅनिश्ड. उडून गेलाय तो बिचारा. कशामुळं? Maybe your concrete is not that much good. Okay. Then danger to the person and property, everyone knows. जर एखादी धोकादायक इमारत पडली आणि त्या इमारती जर मध्ये जर कोणी लोक राहत असतील तर खूप मोठ्या प्रमाणामध्ये जीवितहानी होऊ शकते, सर्वांना माहिती आहे. त्यामुळे तुम्ही तुमच्या सिटीमध्ये, गावामध्ये बघितलं असेल, नगरपालिकेद्वारे किंवा महानगरपालिकेद्वारे ज्या अशा धोकादायक इमारती असतात त्यांची सर्व्हिस लाईफ मोर दॅन 50 इयर्स आहे किंवा त्या पडू शकतात कधी पण. तिथे छानपैकी इन्फॉर्मेटरी वॉर्निंग साइन बोर्ड्स लावलेले असतात, ही इमारत धोकादायक आहे. ठीक आहे, जर त्याने त्याची डिझाईन लाईफ कंप्लीट केलेली असेल. ठीक आहे, किंवा अर्ली स्टेज मध्ये तुम्हाला खूप मोठे क्रॅक्स दिसतात खूप लवकर, तरी सुद्धा ती धोकादायक असू शकते आपल्यासाठी. मध्ये कितीतरी एक्झाम्पल्स तुम्ही युट्यूबवरती सर्च करा किंवा न्यूज मध्ये बघा. अगदी 5 वर्षापूर्वी बांधलेली इमारत मध्ये बेंगलोरमध्ये एक इन्सिडेंट झाला, व्हॉट आय रिमेंबर, वन G+7 or 10 structure, I don't know exactly, but after completing its 5 to 7 year span, the building was get collapsed. Why? Failure in Bihar. Okay, I just remember the recent incidents which was happened. Okay, maybe somewhere in Bangalore, I don't know exact location, but that building was get collapsed. Okay, maybe you are going to see the failure of the bridges also. ठीक आहे, ब्रिजेसचं फेल्युअर पण तुम्ही बघितलेलं आहे. वाय दिस इज गोइंग टू हॅपन? बिकॉज ऑफ इनएडिक्वेट ड्युरेबिलिटी अँड इम्प्रॉपर क्वालिटी ऍट द एक्झिक्युशन ऑफ युअर कॉन्क्रीट वर्क. देन एक्सपेन्सिव्ह रिपेअर कॉस्ट, हे लक्षात घ्या. आय डोंट नो तुम्हाला माहिती आहे का नाही, घर बांधण्यापेक्षा घर पाडण्यासाठी तितकाच खर्च लागतो. ठीक आहे, तुम्ही म्हणत असताना नाही सर बुलडोजर तर चढवायचे, ठीक आहे, किंवा घर पाडणं तेवढं सोपं जाईल मला, मी काय नुसतं हातोडीने सुद्धा पाडू शकतो. नो, द रिपेअर, त्याची डिमोलिशिंग कॉस्ट खूप जास्त आहे जर तुम्हाला घर पाडायचं असेल तर. ठीक आहे, आणि त्यानंतर पाडून परत बांधायचं म्हणलं तर अजून जास्त खर्च येणार. देन नेक्स्ट कॉन्सिक्वेन्स काय आहे, त्याचे परिणाम काय असू शकतात? पुअर परसेप्शन ऑफ द कॉन्क्रीट ॲज अ मटेरियल, पुअर परसेप्शन ऑफ द एजन्सीज विच आर बीन इन्व्हॉल्ड. तुम्ही स्वतःच रेप्युटेशन खराब करताय जर तुम्ही अचीव क्वालिटी जर अचीव केली नाही तर तुमच्या कामामध्ये. ठीक आहे, देन रिडक्शन ऑफ द सर्व्हिस लाईफ. External agencies like weathering, attack by the natural or the industrial liquids, gases, bacterial growths are there. Next consequence, alkali aggregate reaction. काय होतं नेमकं alkali aggregate मध्ये? We are going to study in detail about it. Then ingress of the moisture and the air content, facilitating the corrosion of the steel and the cracking of concrete covers. जर का तुमच्या कॉन्क्रीट मध्ये खूप जास्त प्रमाणामध्ये मॉइश्चर इनपुट झालं, ठीक आहे, then definitely it will leads to the inadequate durability. Okay, so these are the some consequences what will happen to your structure, okay, if you are not going to achieve the proper quality and inadequate durability. Okay. आपल्या construction sector मध्ये you will get a lot of money, huge quantity of money, but for gaining that you require the skilled work, you should be technically sound, and you must have proper quality and adequate durable structures. Okay, whatever the structures you are going to build, that structures must be durable one. तो क्लायंट एकदम खुश झाला पाहिजे, तो कस्टमर खुश झाला पाहिजे, नाही काय घर बांधले सर. ठीक आहे, आज 20 वर्ष झाले घराला क्रॅक सुद्धा गेलेले नाही. बघा आपल्या बाबतीत असं होऊ शकतं का, इतकी क्वालिटी अचीव तुम्ही करू शकता का. ठीक आहे. So you can see some consequences of this inadequate durability. I will use the pointer for the same. Okay, see the pointer. Say बघा reinforcement open up झालेले बघा, इथे बघा reinforcement दिसतंय. ठीक आहे, कव्हरच गायब झालंय, प्लास्टर सगळं उडलंय ते प्लास्टर घरातलं. ठीक आहे, हा तर कॉलम बीम जंक्शन आहे. ठीक आहे, सी द पार्ट ऑफ डिटोरेशन. हा बघा कॉलम दिसतोय, वरचं प्लास्टर सगळं उडालंय. इथे तुमचं आय थिंक हे व्हेंटिलेटर प्रोव्हाइड केलेलं होतं, बट आय डोंट नो व्हॉट इज द कंडिशन ऑफ दिस. ठीक आहे, हा बघा फ्रेम, विंडो डोअरची जी फ्रेम आहे का ती बाजूला झाली. हा बघा कॉलम, सी द कॉलम, द रेन्फोर्समेंट इज गेट एक्सपोज्ड. ठीक आहे, अशा पद्धतीचे जर स्ट्रक्चर असतील ना, 5 वर्षांपेक्षा कमी कालावधी लागेल कोलॅप्स होण्यासाठी. हे बघा वॉटर मध्ये. ठीक आहे, रेन्फोर्समेंट गेट कम्प्लिटली कोरोडेड. हे तर बॉम्बच पडले. ठीक आहे. Okay, so the factors which are going to affect the durability. Chalo, we are having still 5 minutes in our hand. Should I? So no, it's up to 5 now. So we will continue with the 5. Okay. So let us continue. Next part of our discussion is the factors which are influencing the durability of the concrete as per IS 456-2000. Okay, so which factors are influencing the durability? आता तुम्हाला ड्युरेबिलिटी म्हणजे काय हे कळलंय. कुठले कुठले फॅक्टर्स इन्फ्लुएन्स करतात ड्युरेबिलिटीला? फर्स्ट इज द एन्व्हायरमेंट. Second one, the type and quality of the constituent materials. Next factor, cement content and water cement ratio of the concrete. Workmanship, especially in compacting the concrete, where it is very important to compact the concrete. नाहीतर सर अल्ट्राटेक ओपीसी 53 ग्रेड सिमेंट वापरलाय आम्ही. ठीक आहे, 380 रुपयाला आहे बॅग, तरी ती आम्ही वापरली एवढं मटेरियल. ठीक आहे, आम्ही टाटा स्टील यूज केले, जिंदाल स्टील यूज केले आमच्या कन्स्ट्रक्शन मध्ये. बट स्टील इफ यू आर नॉट गोइंग टू कॉम्पॅक्ट इट व्हेरी नाइसली as per our requirement, you are going to see the formation of segregation or maybe the honeycomb. Okay, so compaction is also very much important. Then cover to the embedded steel. Okay, that is the next factor which will influence the durability of the concrete body. Shape and size of the member. Last is shape and size of your member. Okay, it may be your structural element, any element. Okay, let us discuss again few more factors. These factors which are affecting the durability is been categorized. I think flow chart is there. You can see in the next presentation also. So these factors mainly depends on the two important. This durability mainly depends on the two important factors. First, the concrete system, and second one, the service environment. कुठल्या दोन फॅक्टर वरती डिपेंड करणार आहे? पहिली आहे तुमची कॉन्क्रीट सिस्टीम. ठीक आहे, पहिला आणि सगळ्यात महत्त्वाचा फॅक्टर आहे तुमची कॉन्क्रीट सिस्टीम, आणि दुसरा महत्त्वाचा फॅक्टर आहे सर्व्हिस एन्व्हायरमेंट. आता कॉन्क्रीट सिस्टीम म्हणजे नेमकं काय, आणि सेकंड फॅक्टर जो आहे एन्व्हायरमेंट सर्व्हिस. ठीक आहे, तो फॅक्टर म्हणजे नेमकं काय. सो कॉन्क्रीट सिस्टीम इट इज बेस्ड ऑन क्वालिटी and quantities of the material that are used. Quality and quantities of the material that are used. The first factor in case of concrete system. Second factor, processes that are involved in the manufacture of your concrete. मी जसं म्हटलं ड्युरेबिलिटी जर तुम्हाला कधी कोणी ड्युरेबिलिटी जर विचारली तर दोन गोष्टीच महत्त्वाच्या ड्युरेबिलिटीसाठी. एक म्हणजे जे कॉन्क्रीट जे तुम्ही कास्ट केले कॉन्क्रीट सिस्टीम, आणि दुसरं म्हणजे कुठल्या एन्व्हायरमेंट मध्ये तुम्ही ते कॉन्क्रीट कास्ट केलंय आणि कुठल्या एन्व्हायरमेंटला ते एक्सपोज आहे. ठीक आहे. सो कॉन्क्रीट सिस्टीम मधला पहिला एक महत्त्वाचा फॅक्टर आहे क्वालिटी आणि क्वांटिटी ऑफ द मटेरियल दॅट इज यूज्ड, आणि सेकंड फॅक्टर द प्रोसेस दॅट इज बीन इन्व्हॉल्ड इन द मॅन्युफॅक्चर ऑफ दॅट कॉन्क्रीट. आता इन द मॅन्युफॅक्चरिंग ऑफ द कॉन्क्रीट आपण स्टेप्स बघितले आपल्या चॅप्टर नंबर 4 मध्ये, स्टेप्स विच आर इन्व्हॉल्ड इन द कॉन्क्रीट कन्स्ट्रक्शन. मग त्याच्यामध्ये बॅचिंग असेल, सिलेक्शन ऑफ द मटेरियल असेल, ठीक आहे, त्यानंतर त्याचं कॉन्क्रीट मिक्सिंग असेल, त्यानंतर त्याचं ट्रान्सपोर्टेशन असेल, प्लेसिंग असेल, त्यानंतर त्याचं क्युरिंग असेल, मग फिनिशिंग असेल. याच्या आपण स्टेप्स बघितल्यात वेगळ्या, स्टेप्स विच आर इन्व्हॉल्ड इन द कॉन्क्रीट कन्स्ट्रक्शन. खूप महत्वाच्या आहेत. त्यातली एक जरी स्टेप मध्ये तुम्ही गडबड करताल, इट विल अफेक्ट द सेकंड स्टेप and automatically it will ultimately it is going to affect the durability and strength. Okay, so that is all about the concrete system. Flow chart पुढच्या पीपीटी मध्ये बघू शकता तुम्ही. ठीक आहे, पुढच्या प्रेझेंट स्लाइड मध्ये सेकंड फॅक्टर आहे आपला सर्व्हिस एन्व्हायरमेंट. सेकंड फॅक्टर इज सर्व्हिस एन्व्हायरमेंट. सो सर्व्हिस एन्व्हायरमेंट अफेक्ट्स द कॉन्क्रीट बाय द वे ऑफ टू वेज. तुमचा जो एन्व्हायरमेंट आहे ना, हा कसा अफेक्ट करतो तुमच्या कॉन्क्रीटला किंवा त्याच्या ड्युरेबिलिटीवरती कसा इम्पॅक्ट करू शकतो. पहिली आहे फिजिकल ऍक्शन. फर्स्ट वन इज द फिजिकल ऍक्शन अँड सेकंड वन इज द केमिकल ऍक्शन ऑन युअर कॉन्क्रीट. ठीक आहे, बघा ड्युरेबिलिटीसाठी दोन खूप महत्वाचे फॅक्टर्स, एक आहे तुमची कॉन्क्रीट सिस्टीम म्हणजे कॉन्क्रीट बॉडी इटसेल्फ, आणि दुसरं आहे एन्व्हायरमेंट. मग कॉन्क्रीटमध्ये क्वालिटी अँड क्वांटिटी ऑफ द कॉन्क्रीट मटेरियल्स दॅट इज युज्ड, अँड सेकंड स्टेप आहे steps which are involved in the manufacturing of the concrete or the progress. If it is followed rightly in the right direction by following all the rules and regulations or the norms specified in our Indian standard, then it is okay. Second factor, environment. Two actions will be there we need to consider. First one we called it as the physical action, and second one we called it as the chemical action. Okay, let us have the flow chart. I think yes, it is there. Okay, so you can please take the photo, or I will going to upload this PPT in your teaching diary also. So don't worry about it if you don't have. Okay, or you can take the screenshot of this. Factors affecting durability. It has been we need to consider the two important factors. First one is the concrete itself. Second one, aggressiveness of the environment. म्हणजे environment कशा पद्धतीने अफेक्ट करू शकतो. कॉन्क्रीट मध्ये पहिला आहे मटेरियल आणि दुसरा आहे प्रोसेस विच इज इन्व्हॉल्व. ओके, एन्व्हायरमेंट मध्ये फिजिकल ऍक्शन आणि केमिकल ऍक्शन. मग मटेरियल्स मध्ये कुठल्या गोष्टी आपण स्टडी करणार आहोत इन डिटेल. बाइंडर टाइप, दॅट इज युअर सिमेंट. सिमेंट कंटेंट, दॅट इज बाइंडर कंटेंट. बघा सिमेंट कुठल्या टाइपचे यूज करताय अँड दी कंटेंट्स ऑफ द सिमेंट. देन नेक्स्ट मटेरियल इज नथिंग बट द ऍग्रीगेट्स. विच ऍग्रीगेट्स यू आर गोइंग टू यूज. Admixtures, which admixtures you are going to use it. Mixed design, how the mixed design you are going to prepare. Okay, so all these factors we need to consider. These are correlating with the concrete system and ultimately will play a role in having or in the concept of the durability. Now second, the process. In the concrete system, second part is nothing but the process. Process मध्ये जसं मी तुम्हाला सांगितलं, बॅचिंग मध्ये तुम्ही वे बॅचिंग किंवा व्हॉल्यूम बॅचिंग. बॅचिंग नंतर यू आर गोइंग टू मिक्स सिलेक्शन ऑफ द, आधी आहे सिलेक्शन ऑफ द मटेरियल. ठीक आहे, जे तुम्ही म्हटलं बाइंडर टाइप, कंटेंट, ऍडमिक्सचर. सगळ्यात पहिले तुम्ही काय करणार आहे, सिमेंट कुठलं यूज करणार आहे, खडी कुठली यूज करणार आहे, ऍडमिक्सचर कुठलं यूज करताय, आणि त्याचं मिक्स डिझाईन कसं तयार करतात. मिक्स डिझाईन तयार झाल्यानंतर यू आर गोइंग टू ऍक्च्युअल फॉलो द प्रोसेस. सेकंड स्टेप त्यामध्ये आहे मिक्सिंग, weighing as the first, mug mixing, transportation, compaction, curing, finishing, and work temperature and workmanship. ह्या गोष्टी महत्त्वाच्या आहेत आपल्यासाठी in case of the process. Physical factors or the factors which are involving in the aggressiveness of the environment. Physical action and chemical action. Physical मध्ये abrasion, erosion, cavitation आणि freezing आणि thaw हा एक कन्सेप्ट असणार आहे. In chemical action, chemical attack, sulfate attack, chemical attack, or alkali aggregate reaction is also there. Okay, त्यामध्ये अजून एक पार्ट आहे डिसोल्युशन, लीचिंग, एक्सपान्शन and alteration. So all this part, this flow chart we have to consider in our concrete mix design. Okay, all these things we need to consider if you want to achieve the durability. Okay, and how these factors are affecting the durability of the concrete. We will discuss this part in our tomorrow session. Okay, I know it's exact 5 the clock, so we will stop here at this particular time. I will not extend more. So we will take down the further or the rest part of this particular chapter in our tomorrow's or maybe in our upcoming session. So if you have any doubt regarding the today's session, please unmute yourself and discuss with me. If not, okay, just give me a minute to note down your attendance. Just a minute. I will noting down your attendance. Offline students, have you entered this? You have marked your entry? तुम्ही इथे होते का स्वेरीला? येस.
त्यावेळेस लाईट्स काढायचा असेल तर गाईड
हा हा. कुणाला काढायचा?
सर्टिफिकेट घेतले
हा? कुठला?
बोर्ड सर्टिफिकेट डिप्लोमा
डिप्लोमा बेसिस वरती काढायचं.
फायद्याचं
Just so I will take your leave for this particular time. Thank you everyone for attending the session. Have a great day. Goodbye. Take care.